Welcome to the video for Chapter 8 Quadrilaterals, Lesson 4, Rectangles, Rhombi, and Squares. The word rhombi is plural for the word rhombus. The lesson essential question: how are rectangles, rhombi, and squares unique? Let's take a look at how these new quadrilaterals fit into the scheme of all of the quadrilaterals we have talked about so far in Chapter 8. At the very top of this flowchart is the quadrilateral, the most generic definition or word we use for 4 sides and 4 vertices. So the figures with 4 sides and 4 vertices are called quadrilaterals. More specific than just a quadrilateral are the 4-sided figures that have opposite sides are parallel and congruent, and those are called parallelograms. This ... I have down here at the bottom is because if you remember from the previous lesson, parallelograms actually have 5 different properties that make them parallelograms. Those still apply, but we just didn't list them all in this flowchart. So the parallelogram is just a more specific type of quadrilateral because it has those 5 properties. Below this on the flowchart will now be more specific parallelograms, and we're going to start with the rectangle. The rectangle is a parallelogram, and so that is important because it has all 5 of the properties that a parallelogram has, but now even more specifically, it has the 4 right angles. So opposite sides are congruent, opposite sides are parallel, but now also specifically the rectangle has 4 right angles. Another specific parallelogram is a rhombus. The rhombus, again, is a parallelogram, so it has all 5 of the properties previously mentioned in parallelograms, but it has 4 congruent sides. Notice in this example, the angles are not 90. It does have the congruent relationship where the opposite angles are congruent just because it's a parallelogram. That is by definition a parallelogram. The more specific piece that makes it a rhombus is the 4 congruent sides. The final and most specific type of parallelogram is the square. And notice all of the lines coming to the square is because the square has both the rectangle properties and the rhombus properties. And it is, by definition, a parallelogram, so it has opposite sides are parallel, congruent, all of those 5 properties that parallelograms have, but it also specifically has the right angles, like the rectangle, and the 4 congruent sides, like the rhombus. So that all of the properties that apply to a rhombus will apply to a square, because every square is a rhombus by definition, and every square is a rectangle by definition. So again, this flowchart works most generic type of name at the top, quadrilateral, 4 sides, 4 vertices. One specific type of quadrilateral is a parallelogram, but we can get even more specific within the parallelograms with a rectangle, a rhombus, and then the most specific is a square. These shapes also come with the theorem specifically to their diagonals. First theorem is that the diagonals of a rectangle are congruent. So this is a little bit different than just basic parallelograms, because a basic parallelogram, the diagonals bisect each other, but they're not necessarily the same length. In rectangles, they are the same length. The diagonals of a rhombus are perpendicular, so there's no mention of the rhombus being congruent. So we're back to the diagonals being different lengths, but they are perpendicular where they intersect. And lastly, the diagonals of a rhombus are also angle bisectors. So again, rhombus lengths are not congruent, but the diagonals bisect each other at 90 degrees, kind of popping back up to this theorem here, but on the actual rhombus, they are angle bisectors, and we'll take a look at that as we get closer. The other thing to keep in mind here is that all of this applies to squares because a square is a rhombus, a square is a rectangle. So the square's diagonals are congruent. The square's diagonals are perpendicular where they intersect, and the square's diagonals are angle bisectors on the square. So the first task we need to be able to do is identify the quadrilaterals, more specifically based on given information. So the first one says that I am made from 2 pairs of parallel lines. My consecutive sides are perpendicular but not congruent. What am I? Number 2, I am a quadrilateral. My diagonals bisect each other at right angles, which means they're perpendicular. What am I definitely? What could I be? And last one, I'm a parallelogram. I am always these, but they are not always me. What are we? So I will tell you that number 1 has 1 answer. Number 2 should have 2 answers, and number 3 should actually use all 3 of them. And your answer choices are going to be the more specific rectangle, rhombus, and square. Go ahead and pause the video and see if you can figure out which parallelograms they're talking about. Okay, so the answer to number 1 is rectangle, and here is my work, my reasoning here. My consecutive sides are perpendicular. Perpendicular for the consecutive sides means the 90 degrees at the corners, so that's either a rectangle or a square. But those sides are not congruent to each other, which means it has to be a rectangle. So number 1's answer is definitely a rectangle. Number 2, the important piece of information is actually this line right here where the diagonals bisect each other. That will give you either a rhombus or a square, and that pretty much answers this question then. You definitely have to be a rhombus in order to satisfy that factor, that property that the diagonals bisect each other. You're automatically a rhombus. But you could also be a square, you just need more information. Congruent sides, 90-degree angles, that sort of thing. But we need more information about the shape before we can definitely call it a square. But just having this information, we can definitely call it a rhombus. And lastly, number 3 is going to be all of them. I don't suggest really writing your answer down like this. Let me just explain it in words. So a square will always be a rectangle and a rhombus. Every square is a rectangle, every square is a rhombus. But not every rectangle is a square, because rectangles can have 2 sides different from the other 2 sides in length. But it will always have right angles, just like a square will always have right angles. And same thing with a rhombus. All squares are rhombi because they all have the same, all 4 sides are congruent, but not every rhombus is a square because a rhombus by definition does not have to have congruent angles. That part can be a little tricky. It's one of those, a square is always a rectangle, but a rectangle is not always a square. Okay, let's start to use the information to find missing angle measures. Because this shape is a rhombus, that allows me to make a 90-degree angle here at the diagonals bisecting, because that's what it means to be perpendicular. I'm given that the measure of angle 1 is 38 degrees. Because it is a rhombus, the diagonal is also an angle bisector here, so that means that this is also 38 degrees. And if you remember from properties of parallelograms, if this is 38 down here, then it's also 38 up here. We had that alternate relationship that presented itself in parallelograms in general. So this is 38 degrees. Because it's a rhombus, this is also 38 degrees. So we were able to find a lot of information about the angles just by given 1 and the fact that it is a rhombus, which is a parallelogram. Now, also being a parallelogram, that means that the consecutive sides are supplementary. So 38 plus 38 is 76. If I take 180 and subtract 76, I get 104 degrees. So that's the measure of this whole angle here of 104 degrees. Because it is a rhombus, this diagonal is bisecting this angle. So this is actually 52 degrees and 52 degrees. And because it's a diagonal of a rhombus, it's actually 52 degrees up here also. So let's see if we've answered all the questions that we need. Measure of angle 2. Measure of angle 2 is going to be 90 degrees. So that's there. Measure of angle 3 is down over here. That's 52 degrees. Measure of angle 4 is 38 degrees. And then the measure of angle DAB, we have to follow the letters D to A to B. So it wants this whole angle on the rhombus, which we found to be 104 degrees. So we have found all of our pieces just by being given one angle measure and the fact that it's a rhombus. This next problem, again, is a rhombus, but in this one, it looks like we are being given length information instead of angle information. So this says that AC is 20. So what I'm going to do, instead of identifying the whole thing as 20, I'm going to go ahead and make it 10 and 10 because it's a parallelogram, so the diagonals bisect each other. So DB is 28. DB is the whole diagonal, so I'm going to make that 14 and 14. So again, because it's a parallelogram, just a basic parallelogram, the diagonals bisect each other, so they cut it in half. The rhombus is not going to have congruent diagonals. This is 28 and this is 20. The congruent diagonals come from rectangles and squares. All right, so let's see if we can figure out how to find the measure of DC. Well, DC is out here. Now, if we look, we have the diagonal information, and I'm trying to find information about a side. Luckily, this is a rhombus. So what that's actually telling me is that this is 90 degrees in here, which means now I have a right triangle where the x is the hypotenuse, and I can use the Pythagorean theorem, 14 squared plus 10 squared equals x squared, and you can use the c there if you want for a squared plus b squared equals c squared. I'm just going to leave it as the x. When we solve, we will be finding the length of DC, or the outside side of the rhombus, and because it is a rhombus, they're all going to be the same. So all of these sides are 17.2. In this last example here, we need this information. We at least need that this is a 9 here, so make sure you have this drawn in your notes. And I'm not even going to worry about the information that it's asked for. I just want to use the fact that this is a square, and I've got diagonals, it's intersecting, diagonals are intersecting at point E, and I'm just going to label everything I know just from the fact that it's a square. And that's that all of the outside sides are 9, that it's 90 degrees where the diagonals bisect each other. The diagonals are congruent and bisecting each other, so all of those are also the same. I also know that it's 90 degrees at each corner, but I also can say that the diagonals are bisecting each other. So instead of just being 90 degrees, I actually know that it's 45 and 45 at each of those angle measures. So 45 degrees and 45 degrees everywhere, because the diagonals are angle bisectors also. So that will help us answer a lot of these questions over here. I think for one or two of them, we may also need the Pythagorean theorem. But for this example, all I really wanted to focus on was what we know just from the fact that it's a square. That concludes the video for the lesson 4 on rectangles, rhombi, and squares. How are they unique? Unlike other parallelograms, rectangles and squares have 4 right angles. Rhombi and squares have 4 congruent sides. Notice that this answer does not mention any information about the diagonals, and that was simply just to keep the lesson essential questions answer pretty short. But please know that you do have to remember that the diagonals that happen with rectangles and rhombi, so that way you can use that information to find missing values.